Yeah. Sir, in the last videos, I think we are discussing about okay, tree data structure, right? We are talking about the tree data structure. In that, I explained very clearly various operations that we can able to perform on binary search trees, right? We are talking about binary search trees. If you see the program, like we implemented, we created binary search tree. In that node class we have seen, and how to create that constructor we covered, and how to insert the elements into the binary search tree we have seen. Sir, how to insert the elements into the binary search tree? For example, if you see here, what is the first element that we inserted? 6, the order I'm explaining. So first we are trying to insert 6, and then 4, and then 8, and then 1, and then 5, and then 9, and then 10. Like this we are inserting. Sir, in this case what will happen? How we are going to insert? Sir, first we are going to take the data which we are trying to insert, and if the node is empty, the node which we have created will become your root node. Then, sir, next when we are inserting the element called 4, sir, what will happen? Since the node, the tree is already existed, we have to compare node dot data. What is the node here? 6. Sir, its data is 6. Is it greater than, or is it greater than the data which you want to insert? The condition is satisfied. So we have to create this node to the left side of this particular 6. Then next element is 8. Is node is equal to none? No. Sir, that 8, is it greater than node dot data is 4? Sir, is 4, is it, sorry, 6, right? So is the 6 is greater than 8, condition is not satisfied. So where it is going to be inserted? To the right side. Next we are taking 1. First it will compare with the root node. Since it is less than, it will come to the left side. Again it is less than 4. That's why it will be inserted here. Next, if you take 5, it is less than 6 and it is greater than 4. It will be inserted here. If you take 9, it is compared with the root, it is greater, it will go to 8. And when compared with 8, it is greater than 8. So that's why we are going to get here. And 10, compare with the root node. Since it is greater than the root node, it will come to the right subtree. In the right subtree, it will compare with 8. Again, it is greater than 8, it will go to 9. And since it is greater than 9, we can insert here. This is nothing but, sir, how insertion operation is performed in binary search tree. Okay, sir, that operation we have seen. And how to search for the element. We will start comparing with the root element. If it is not there, we will search in the left subtree. Otherwise, we will search in the right subtree. How to find the minimum element? Sir, if you take any binary search tree, the element which is available at the leftmost subtree is nothing but the minimum. How to find out a maximum? The element which is available at the rightmost subtree. And we have seen one more function, like how we can able to remove leaf nodes. Sir, how to remove leaf nodes? You can see whenever you are traversing the elements one by one, we are going to check, is the node is equal to none? Okay, if node is equal to none, simply we will return none. Otherwise we are checking, sir, is there any node in the left side and is there any node in the right side? If left side node, right side node, both are not there, simply we are going to return none. Okay, that means what? We are making that node as a empty. That part we have seen. Then how to print the elements from root to leaf? So just by taking a list and we are keep on adding the elements, that part also we have seen very clearly in the last session. Then level order traversal, pre-order, post-order, that you can do by yourself. How to print the elements in the level order? If you take this particular tree, sir, what will be the level order here? Sir, we are going to get 6 in the first level, like that. Let me cross check. Just we will try to execute this program and we will check really is it happening or not. Sir, here I think already I created one folder with name DSA with Python. So here we created one file with name, so BST. So now you can see in the top we have 6, and in the next level 4 and 8, in the next level 159, in the next level 10 is there, like that we have. So these operations we have seen very clearly in the last videos, sir. Okay, now what we have to do, my task is I want to delete the element, sir. Okay, we have to perform delete operation. Okay, sir, delete operation is not that much easy, sir, because multiple cases will be there in this. So what is the next operation that I'm going to perform? So delete. So delete operation on BST, binary search tree. Sir, there are three cases will be there. What is the case one is nothing but, so deletion of a node, deletion of a node, sir, which is having no children, which is having no children. Sir, means what? Suppose if you take one simple example, observe carefully. Suppose consider I have a node 10 is there, and inside this we have a left subtree 2 and a right subtree. So 6 is there. Sorry, right subtree 15 is there. In this case, I want to delete the node called 15. Here, I want to delete which node? 15. Is this 15 node is having any children? No, right? Then there is no issue at all. Simply we can able to delete this node. Okay, so if that node is not having any children, directly we can delete, sir. Okay, so how you can able to do? Directly we can delete. Sir, second case, so deletion of a node, deletion of a node which is having one child. Sir, I have one child is there. In such cases, how you can able to define? In this again, I can explain in two ways. For example, consider I have node 10 is there. For this 2 is the left child and 15 is the right child. 15 is having 13 as a left child. This is one case. Okay, so another case for 10, we have 2 is there and the right subtree is a 15. For 15, 17 is the right subtree. Like this we have. In this example, I want to delete 15. Sir, if you want to delete 15, what we have to do? How many children are there? Only one children is there. Sir, can I delete this element and can I make this 13 as a root node? Like this we can do. Okay, sir, in this case, we can remove this 15. Okay, after that, we can make this 17 as a parent. Like this we can do. Sir, either in, it may be any case. What we have to do here? So delete. So delete that node and so make its a left child, its a left or right child. Okay, as parent. Like this we have to do. Sir, can you please confirm in this binary search tree? Is these two cases are clear for you people? Please confirm.
Yes, sir, clear.
Yes, sir. Clear.
Right. So what about the third case? I think you can able to tell. What will be the third case? Can anyone tell?
Both left and right.
Yes. So deletion of a node. So which is having. So which is having two children. Two children. Sir, in such cases, what will happen? It is a very difficult task, right? So because I will take one example for this. Okay, just for convenient purpose, so I'm taking one simple example. Have a look once. I have 10 is there. So for this left child is a 5 and for this right child is a 15. For left child we have 1 and right child we have 6. Now assume I want to delete this element called 5. I want to delete this element called 5. Sir, you can't take directly. So 1 as a child, 1 as a parent node or 6 as a parent node. We have to apply some technique, sir. We have to apply some technique and then we have to find out the parent. Can you please guess me which can be parent among
Both
this 1 and C?
anyone.
Anyone? Anyone can we make it as a parent? Suppose
Yes, sir.
consider, please listen carefully. Suppose consider, I am taking the same example. So 10, we have 5 is there. Assume here, instead of 6, I am taking 7. Okay. So here 15. And for this 5, left child is 1, right child is a 7. Assume for 7, 6 is the right child, 8 is the, 6 is the left child, 8 is the right child. Here I want to delete 5 element. This 5 node is having 2 children. Now can you tell me among these two which will become the left child? I mean, which will become the, which is going to replace that 5? Tell me.
1.
1. Correct? Right. Sir, in this case, what we have to do is, you need to find out in order for this tree. What is the in order? Can you please tell me? In order
Yeah.
means what? First one, left, and then root
Root
node, and
node.
then
7, 10,
right.
15.
Right.
So 10. 10 is nothing but it is again having left child. Left child is again a tree. That's why. So first left node, then root
5,
node, then
7,
7, and then
10, 15.
10, 15. This is the in order what we have. Got it? Sir, now can you tell me for this tree, what is the in order? Yes, for this tree, what is the in order?
6, 7, 8.
1, 5, 1, 5,
1,
6, 5,
1, 5.
5,
Right
6.
child is again a tree, right? So 6,
Yes.
7, 8. Is it
6,
correct?
7, 8,
Hmm.
10,
10,
15.
15.
10, 15. See, so if you want to delete a node which is having 2 children, sir, you have to do, sir, one small activity. What is that activity is, try to find out in order successor for the node. Sir, which node you are trying to delete? The node 5, right? What is the in order successor for this 5? 6. The 6 will become root node. In this case, what is the in order for 5? 7. 7 will become root node. That means here 7 will come and this will be deleted. In this case, what will happen? 6 will become root node. Okay, 6 will become root node. Again, we have to delete this 6, sir. Okay, after making this as a root node, we have to delete this 6. Like this, we have to find. Sir, I will give one shortcut for you. Okay, what is the shortcut is, sir, in order successor means what? Definitely it will be there only in the right side tree. In order successor means it will be there only in the right side. Sir, can I find minimum element in this and then I can make that minimum element as a root node? Yes, definitely. Since it is a binary search tree, in the in order successor, if you have a tree, you need to find out always minimum element. That minimum element, I am making it as a root, sir. I think the concept is clear for you at least now, right? Any doubts? Yes, please confirm. Any doubts up to this, whatever I
Sir,
covered?
can you please explain about minimum element? I'm not getting this point.
A minimum element is nothing, sir. This in order successor you got, right?
Yes.
So if you take any tree, not only this one, if you take any tree, so I want to find out in order successor for 6. What is the in order successor for 6? So first left subtree,
1,
after that
1, 4, 5,
no.
6.
Yeah, 1. So 4,
5,
okay,
6.
5, 6, and the next element
Next, 8.
definitely be 8. 8 is nothing but in order successor for 6. Is it correct?
Okay. Yes.
Suppose if any element is there like 7 here, then which one will become in order successor? Not 8. It will become 7. Why? Because after visiting left subtree, after visiting root node, we are going for right subtree. In the right subtree, again first we have to visit left. So minimum element will come. Are you getting my point, sir?
Yes. Yes.
So that minimum element concept I am taking here. Beyond that, nothing. Okay. So remember these 3 cases. What is the first case? If you want to delete a node which is having no children, directly we can delete. We are not required to make any pointers. Second case, if you want to delete a node which is having only one child, we have to delete that node and we have to make its left child or right child as a parent, because only one node. So it can be anything. It can be, suppose if I delete this example, if I want to delete 9, sir, can I replace in the place of 9, 10? Yes, no problem. Suppose if I want to delete 5, sir, simply you can delete. No need to make any changes. If I want to delete, sir, in this place, which node you have to keep? Sir, don't tell that 8 we have to take or 9 we have to take like that. Suppose if you take 8 here, if any 7 is there, if 8 is coming, sir, is the 7 is greater than 8? No. So leftmost smallest element you have to find out, make that element as a root node. Like that we have to do. These are the three cases which we have if you want to perform deletion of a node which is having two children. Okay, sir, if this delete operation is clear for you people, I will go with the implementation of the program. Can you please confirm, is the concept is clear?
Yes, sir, clear.
Yes, sir. Clear.
Yes, sir. Clear, sir.
Right. Sir, we will see one example program so that you people will get clarity. Okay, whatever concept I told, just I am trying to implement. Okay. Sir, now what I am going to do is I will write a code, but before that I want to take a meaningful tree. So consider I am going to take like this. So the first element is nothing but let it be 6. Next, its left subtree is nothing but something like 4, and its right subtree is nothing but 8, and 1 will be its left subtree, 5 is its right subtree, and for 8 after 5 I want to insert 7. Okay, after this I want to insert 7. So next and after that, so we have inserted 9. Okay, otherwise we will insert 10. So then we will insert 9, and then we will insert 12. Sir, after 7 uh, we are going to insert, after 7 we have to insert 10. So then after that we are trying to insert 9. After that we are trying to insert 12. So now I will do one more thing. So I will try to insert one more element called, let us take let us take 2. Okay, let us take 2. Sir, where the 2 will be inserted? I think here it will be inserted. Right. Sir, now I want to insert 2 at the last. Now let us run this code and check really is the tree is came. In the first level 6, in the next level 4 8, in the next level 1 5 7 10, in the next level 2 9 12. Yes, perfectly it is there. Okay, still if you want to get confusion, better to take 13 also, so that what will happen, that the 13 will come in a new level, so that just you can get clarity. Sir, for explaining the delete operation, these are the elements that I have taken. Can you please confirm, is it clear up to this?
Yes, sir, clear.
Now, sir, I am going to write the functions. Listen carefully. Sir, I am taking one function called delete, which is going to take self and the data which you want to delete. Sir, self dot root is equal to, so I am calling util function like a delete underscore util function just by passing self dot root comma the data what you are going to delete. So we have to write code for delete underscore util function. Sir, here self, and I am going to represent node and then data. So we have to write code for this. Sir, first code I am trying to explain. Sir, t dot I am calling delete function. So I want to delete which node, sir? Consider I want to delete 5. Sir, let us see how the control is going to come. Please listen carefully. Sir, if you want to perform delete operation, first we need to perform search operation or not, because we have to check where the element is available. Sir, which nodes we are passing here? I am going to pass a 6, and then the data is nothing but what? This is the node, and the data is nothing but what? We are trying to delete 5. Okay, and here I'm going to take temp is equal to initially none, and I'm going to check is node is not equal to none. Sir, yes, my node is not equal to none, and I'm going to check is node dot data is equal to the data which you are trying to delete. Sir, what is the node data? 6, and the data which you want to delete is a 5. Is both are same? No. Then I will come out from this. Later we will write code for that. Okay, sir, else what we have to do? Sir, very simple, we are going to check. Okay, yes, sir, we are going to check. Else I think we have to write one more condition, right? One more condition we have to check. What is that condition? So better I will write here, if else, that is if node is not equal to the data, then else part. In the else part, two possibilities will be there. What is the first possibility? The node dot data value, is it greater than data? We are checking. Now have a look once. Sir, what is the node dot data? So 6. Is it greater than the element which you are trying to delete? No, right? This element is greater. In such a cases, what we have to do? Definitely the data which you are searching is available in the left. Node dot left is equal to, sir, I am going to take self dot delete underscore. I am going to call util function by passing node dot left comma data. Can you please search in its left child, so that what will happen? It will come here, node comma the data which we are searching is 5. Now again the same function will be called. Is node is not equal to none? Yes. Is node dot data is equal to your data? No, sir. Then what will happen? Node dot data, that is 4. Is it greater than 5? Condition is not satisfied. So if this condition is also not satisfied, definitely the element which you are searching will be available in the right. How you will search? Node dot right is equal to self dot, can you please delete utility function by passing node dot write comma the data which you want to delete. So automatically what will happen, sir? The control will come here. Sir, the control, this particular control will come here, right side. Sir, the data node is nothing but this one, and the data which you want to delete is 5. Like this we have. Now have a look once. Sir, again since we called delete util, temp is equal to none, node is not equal to none. Yes, 5 is not equal to none. And the node dot data is 5, and the data which you want to delete is also 5. Like that we came. Sir, now we came to the exact position where we have to delete. Can you please confirm, friends? Is the concept whatever I covered up to this, is it clear for you people?
Yes, sir, clear.
Any doubts up to this, whatever I covered, please confirm.
Clear, sir.
Clear?
Yes, sir.
No. So just a second. One emergency call. Just a second. Yeah, right. So node dot write is equal to self dot delete util. So just we pass it like this. Sir, we came to the exact position where we have to delete the node. Sir, which node we have to delete? The node 5. We came to that location, right? Sir, now what we have to do? We have to delete that node. Sir, how to delete this? Sir, very simple. Please understand clearly. First, we are going to check. Sir, whenever you came to the position, we are going to check case 1. What is the case 1 I told? If that node is there, right? So please check, is that node left child is equal to none and that node right child is equal to none. Please check, is that node left child is equal to none and right child is equal to none. If it is the case, can you please return none? Now have a look once. Sir, who called this? Node dot right. Okay, this node is there, right? For the right field we are talking. For the right field we are talking. I will mark in some other color. This node right field we have called this one, right? Sir, now this right field node we got, that data is matched. Sir, this is the node now. Is it left child is none? Yes. Is it right child is none? Yes. Can you please return none? Means what? Sir, who called this? This one, right? For them we are going to return none. That means node 4 its right child is nothing but what? None. That means what? This entire data is going to be deleted. Okay, sir. Now, after doing this operation, what will be our result, sir? Sir, finally, we have to return the control to the root. So, return node. Sir, now what will happen? Since we are deleting 5, its left child and right child is not there. Automatically, this 5 is going to be removed. Let me cross check. Sir, is it happened? 6, 4, 8, 1, 5, 7, 10. So 2, 9, 12, and then 13 is there. Sir, after deletion, 6, 4, 8 is there. 1, 7, 10. Have you observed 5 is not there? Sir, 2, 9, 12, 13. Sir, which elements we can able to delete from here? Boss, we can delete 2 because it is not having left child and right child. We can delete 5. We can delete 7. We can delete 9. We can delete 13 because all these are nothing but leaf nodes. So this is nothing but the special case for leaf nodes. I think you understood this case. Any doubts?
No, sir.
No, sir.
Clear?
Yes, sir.
Yeah.
Now, sir, what is the next activity? Sir, what is the next activity that we have to do? We have to write case 2. Sir, case 2 means what? Consider the node 5 is there. Okay, consider the node 5 is there. Now, sir, which node you are trying to delete now? So consider I want to delete. Sir, which node is having only one child? Sir, 1 is nothing but having the only one child. That is nothing but its left child is there. Now have a look once what will happen. So first, all these cases I am going to explain. What is the first case? Sir, is node is not equal to none. Yes. Is node dot data is equal to the data? No. Then what we have to do? You need to check is node dot data is greater than node dot data is 6. Yes, it is greater than the data which I want to delete. So immediately node dot left, whatever operations we are doing, it should reflect to the left child of 6. So this is nothing but my node now, and the data is nothing but 1. Now what will happen? Sir, self dot delete util. Again, is the node is equal to data? No. Then what we have to do? Sir, we have to check. Is node dot data, that is 4, is it greater than the data which I want to delete? Yes. Again, it is there in the left chain. So it will come here. Node comma 1. Now, sir, is node dot data, that is nothing but 1. Is it equal to the data which we are deleting? Yes. So now here we have to write. And when you are doing operation, if you return anything, where it will be returned? Sir, who called this one? Sir, 4 left child, right? 4 left child. For them, we have to return. Keep that in mind. Okay, if you are doing any modification here, that will be attached to the 4 left. Sir, now have a look once. Sir, first case, it will check case 1. Is the node dot left? What is the node 1? Is it left child equal to none? Yes, sir. Is right child is equal to none? No, sir. Then the first if condition is not satisfied. Then one more if condition. What is that one more if condition? Sir, this first case is not satisfied. If the first case is not satisfied, then internally I entered into the, it is not a leaf node. If it is not leaf node, again 2 cases will be there. What is the second case here? Sir, we are checking is node dot left is equal to none. Is node dot left is equal to none. Sir, is node, which node is there? 1. Sir, is it left node is equal to none? Yes. Then what we have to do? Sir, can I take temp is equal to node dot right? Temp is equal to node dot right. Sir, which will become temp now? Node dot right. This will become now temp. Okay. This will become temp reference. Sir, after that, what we are doing? We are returning that temp. Directly also we can return. Sir, which one we are returning to? That means who called this? 4, right? For them, we are returning to. Automatically, so this will be gone. This will be gone. And this link will be attached to this. Like this we have. Okay, like this we have. Sir, sometimes maybe left child will be there. then what will happen? Sir, if node dot right is equal to none, if right child is not there, then temp will become node dot left and we have to return that temp. So I think second case is very clear for you, sir. Please confirm, is the concept is clear up to this whatever I covered?
Yes, sir.
Sir, is the second case is clear? So what we have done in the second case, just we are checking its child which is having only one children. If one children is there, then what will happen? Whether it may be left or right, that node we are attaching to the main node. Now let us see this second test case. Sir, which elements are having only one child? Can I take one? Yes. Now see what will happen. Sir, initially in the third level, you can see 1, 5, 7, 10 is there. Okay. Now, which one will become root node? In the place of 1, 2 came. Sir, 2, 5, 7, 10. In next level, only 9, 12. Sir, next one more element is there with only one children, which is nothing but a 12. Sir, if I delete a 12, sir, what will happen? Now have a look once. 1, 2, 3, 4. In the fourth level, 12 is there. But that 12 is gone. In the place of that 12, we got 13. Sir, is there any other node which is having only one child? No, right? So we can't delete remain. So this is nothing but a case 1 and case 2. With live execution, I have shown case 1 and case 2. Can you please confirm if these two cases are clear? Next one, the difficult case we are going to study. Clear, sir? Please confirm.
Yes, sir, clear.
Now, please listen carefully. Sir, the initial node which I want to delete is nothing but consider 10. I want to delete which node? 10. 10 I want to delete. Sir, first control came here. Is node.data is equal to data? No. Then it is available in the right side. So node comma 10 and it is available in its right side node comma 10. Now you can see up to this we came node.data is equal to data. Yes, now my data is 10. Is its left child is none and right child is none? No, both are existed. So this if condition not satisfied. Second case, is its left child is none? No. Next, is its right child is none? No. That means if all these cases are not satisfied, sir, then important case we came, that is nothing but the last case. Okay, which is nothing but case 3. Sir, now we have to write a code to delete that element. Sir, how to do that? Sir, I am taking max node, some variable I am taking, max node is equal to, sir, I will write a code. Sir, find max underscore util function I am taking node dot left. Sir, in its left child, I am finding maximum element. In its left child, I am finding maximum element. Okay. Sir, which will become root node here? Try to find out in order successor.
9.
9 should not, sir.
Sir,
Actually,
12.
12 should come, right?
12.
Can I make 9? Check all the cases, sir. Can I find 9 and I can make it as a root? If you make 9 as a root, then 8 greater than 12 like that. Suppose if you take 8, if you delete 8, can I make 7 as a root node? 7
Yes.
like this. Suppose if I want to delete 6, what is the maximum node in the left side is 5. Can I make 5 as a root node? Yes, we can do that. I told in order successor, right? In order successor. Check in that possibility. Can I take this in order successor is nothing but 12. Can I make 12 as a root node? If you make 12 as a root node, then again we have to disturb 8 in 8. 8 in order successor is nothing but 9. Can I make it as 9 as a root node? Yes, possibility is there. If you delete 6, can I make 7 as a root node? Because in order successor is 7. Yes. So in order successor or even just now I covered, right, which is nothing but pre-order successor. Can I take pre-order successor also? Now identify what is a pre-order for this tree. Better up to this try to find out the pre-order successor. I mean pre-order. What is a pre-order? First left subtree or which one?
Root left, right.
First root right.
Yeah, root left, right.
Yeah, first we have to take 8 and then 7. So and then 9 and then so 7, no 8, 7. Then we have to take a 10. So next 9. So next we have to take a 12 and then 13. Is it correct? So what is a pre-order successor? 9. Yeah, we can take in-order successor or pre-order successor. Anything you can take, sir. Sir, if you want to take pre-order successor for the node 10, how to identify pre-order successor? Is it a maximum element present in the left subtree? Yes. If you maximum element in left subtree. Sir, if I want to find out in-order successor, can I take it is a minimum element present in the right subtree? Anything will become root node. Sir, both possibilities are there, right? Yes, anything will become root node. But levels are going to be mismatched. Beyond that, nothing. Can you please confirm is the theoretical concept is clear?
Yes, sir.
Right.
No,
Sir,
sir.
yes.
In order is a pre-order. This concept is not understand.
Sir, already in the last class I explained. If you take any tree, for example, 10, so 10, or let me take so 10, and if you have 5 and then 15 like this, if you have any element, this is a root element and this is a left subtree and this is a right subtree. So in order means what? First we have to visit left subtree and then root node in the middle and then right subtree. This is called as in order. If you take a pre-order, so first we have to visit a root node, then left subtree, then right subtree. If you take post order, so first we have to visit left subtree, then right subtree, at last root. This concept already I covered, sir. Same concept I am repeating here. Okay. Please cross check the previous videos. Okay.
Okay, sir.
Right. Sir, now what we have to do? You need to find out which one, sir. In order successor, we have to find out. In order successor, we have to find out. Or pre-order successor, anything. But here I'm going to find out the maximum node. That means what? Pre-order successor, we are going to find out. Sir, let us see how we can able to do that. Sir, we have to write a max function. Unfortunately, in the previous sessions, somewhere I have written the code to find out maximum element, but not a maximum node. I need maximum node. So I will write a utility function somewhere max find maximum element. The code is there, but I don't want a maximum element. I want maximum node. I want. Then what we can able to define? Sir, we need to define max util function. Okay. Sir, find max, or what is the function name that we have taken? Max node is equal to find max util. Okay. So find max util of, I'm going to pass one node. We have to find out that node maximum element. Now let us see. If your node is equal to none, then nothing is there. Simply I am going to return none. Okay. Sir, if node is not none, then what we have to do? Until your node dot right is not equal to none, sir, we have to keep on move to the right side, sir. We have to keep on move to the right side. At last, in previous example, we returned node data data, but I need only node because I don't want a data. That's why I have taken like this. Sir, now what will happen? Sir, since you are calling max node is equal to, I am writing in the green color, listen carefully. find max util of node dot left. Now node is a 10, right? So it's a left subtree I passed. That means this tree is passed as a argument. In this we have to find out max util. Sir, now observe carefully. 9 is given as a input. Okay, 9 is given as a input. Is 9 is equal to node? No. Is 9 right node is not equal to none? Sir, 9 right node, it is equal to none. So it will come out from the while loop and it will return node. Sir, which node it is going to return? 9. So your max node will become which one, sir? 9. Suppose consider I want to delete the node called 6. I want to find out max node. What will happen? Sir, since you have given node is equal to 6, it is not equal to none. And node dot right, it's a right node. 8, it is not equal to none. It's a right node we are checking. Sir, 10, it is not equal to none. It's a right node we are checking. Okay. So it's a right node we are checking. 12, which is not equal to none. It's a right node we are checking. Okay. Sir, one second, there is some small issue. One second, sir. If you want to delete the node 6, if you want to delete the node 6, it's left subtree we are passing. Okay, it's left subtree we are passing. That means if I want to delete 6, it's left subtree. This one we will pass 4. Sir, in this we have to check the maximum. In the left subtree, maximum node will become this side, right? Sir, is node dot right is not equal to none? Yes, then move to here. Is node dot right is not equal to none? Sir, node dot right is none. It will come out, it will stop here, and your maximum node will become what? 5. Similarly, in the 10, maximum node will become 9. Sir, can you please tell me maximum node of 8? Sir, for the 8, what will be the maximum node, sir? Can you please confirm?
10.
Oi, for 8, you have to pass left subtree as the input. So you have to search in the left subtree. Which one will become max? We have only one
7.
node is there, that is 7. Sir, what is the maximum node in 4 left subtree? 4 is there, right? It's if I want to delete this 4 among this 1, 5,
2.
2, which one we have to make it as root? 2. That's why 4 left child we are passing. In this right element is there or not, we are checking. This is nothing but how this max node function is going to work. Sir, already we implemented this find max and we came to know that 9 is nothing but the maximum element what we have. Okay. Sir, I found 9 as the maximum element. Sir, then what we have to do? Sir, very simple, sir. We have to check. Okay. So we have to do one small operation. What is that operation? Is node dot data is equal to max node data. Sir, what is the node dot data? Please listen. I'm going to highlight in blue color. Sir, what is the node data data? The node which you want to delete is nothing but which node, sir? 10 you are trying to delete. Sir, this node data is equal to, I am erasing this and I am going to copy which node, sir? Max node data. What is the max node? 9. That I am going to assign. Beautiful. But after this, we have to delete this 9 or not? Yes. Again, this 9 may have a child. So 9 may have a child, left child, or 9 may have right child, or 9 may have 2 children. So how you can able to find out that? Okay. So that's why what I am going to do is, sir, very simple, sir. Node dot left. For that left subtree, I am going to call self dot, again I am calling, so delete underscore util function by passing node dot left comma that max node data. Sir, what is the max node data? The max node data is nothing but what? 9. I want to delete the 9 in the node dot left. Sir, what is the node here? 10, right? Sir, its left will become what? 9. So in this, I want to delete the data 9. Now we got this data. Again, delete operation. Is it having left child as a none? Yes. Is it having right child as a none? Yes. Then immediately what we have to do? We have to return the value called none. We have to return the value called none. That means it is gone. Now you can see, sir, is the node got deleted or? Yes. Sir, this is nothing but the code what we have. Okay. Sir, now let us execute. Let us execute. I want to delete which node, sir? Just now we tried. The node which we are going to delete is nothing but a 10. Okay. Let me cross check. Now you can see. So 15710 is there. 1579 came. In the next level, sir, 2912 is there. 212 is there. Like that we have. Now, sir, please listen carefully and tell me the correct answer. Sir, previously, this is our node, right? This is our data. This is our data. Now, please tell me if I am going to give any node name which I want to delete, you have to tell in that place which node will come. Suppose consider we tried with the 10. Okay. One second. So here which node was there? 10, right? Now, sir, the node 10 got deleted. Suppose tell me if I want to delete node 8, in the 8th node place, which node will come? Please tell me.
7.
9.
7, sir.
Why 9 will come?
Sir,
In the
maximum
right,
element left side.
no, all maximum element left side. We are deleting 8. What is the left side to the 8? We have only 7. In this, what is the maximum element? 7, right?
Yes.
So 7 will become your root node.
So only that particular tree will be considered, or the whole tree will be considered after 8th node?
After 8th node, only 8th left subtree will be considered. Remaining things it won't consider. That's what we have passed here, right? In the program, if you see the code, so first we are finding the maximum node, right?
Yeah.
So we are finding maximum node to the left subtree of the node which you want to delete. If I'm deleting 8, it's left subtree I am passing as argument to find the maximum. Got it?
Yeah.
Now, sir, next one. So let me cross check. Is it correct? Yes. Sir, 4, 8 got deleted. In the place of 8, I got 7. Now consider I want to delete the node called 4. Tell me which node will become root node now?
1.
2, sir.
Because for the 4, left subtree is nothing but this tree. In this, what is the maximum element? 2, right? That 2 should will become root node. Now have a look once. Initially 6, 4, 8 is there. Since we deleted 4, in the place of 4, we got 2. Okay. And in the next level, 1, 5, 7, 10, it won't be disturbed. But in the next level, 2, 9, 12 is there, but that 2 will be gone. So now very, very important. If I am taking 6, which node should become root node?
4.
Huh?
No, 5, 5, 4.
5. Because 6 left subtree. 4, 1, 5, 2 is there. In that, which is the maximum? 5. That will become the root. Now you can see. 5 is the root node. 4, 8. Left subtree, right subtree. Sir, 1, 7, 10. 1, 7, 10. Because 5 make to the root node. And remaining nodes are as it is available. Got it?
Yes, sir.
Yes, sir.
This is nothing but, sir, the operation on binary search tree what we have. Sir, any doubt in this?
Yes.
Clear?
Clear, sir.
Right. So practice up to this. Okay. So today evening, again, we have a session with the same link. So today evening, we have class. Today evening, we have a class at 8:15 p.m. to around up to 9:45 p.m. I will take. Okay. So the topics is nothing but I'm going to take AVL tree and then I'm going to cover PQ, priority queues. These two things will be covered. And please make sure AVL tree is the same like binary search tree. Only few operations we are going to change. While coming to the evening class, please refer this binary search tree very clearly. Then only you can able to understand this AVL. So I will ask admin team to upload this video immediately. So I request you people to watch the video one more time and come to the evening class. Okay. Evening we have a class at as usual 8 o'clock. So 8:15. 8:15 to 9:45 I will take. Okay.
Yes, sir.
Yes, sir.
Right, sir. Thank you. See you in the evening.
Thank you, sir.
Thank you, sir.
Right. Thank you.